Welcome to 4.2, Patterns and Linear Functions. Our goal for this lesson is to identify and represent patterns that describe linear functions. So we're going to be looking at patterns and learning more about what linear functions are. So in a relationship between variables, the dependent variable changes in response to the independent variable. So this is an extension of what we learned in the previous lesson. The dependent variable is relying on the independent variable, and that dependent variable changes depending on what happens with the independent variable. So those are the first couple blanks on this page. Now let's talk about what inputs and outputs are. Inputs are the values of the independent variable, and outputs are the values of the dependent variable. So the output depends on the input value. And the relationships between variables can be represented using tables, words, equations, sets of ordered pairs, and graphs. So many representations. Here we have example 1. In the diagram, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and graph. So take a moment to look at the figure below. We have one rectangle. It has a width of 6 and a length of 1. The next one has a width of 6 and a length of 1 plus 1, etc. So as you can see, the ones are increasing on the top and bottom. So the first step is to organize this information with a table. So the number of rectangles in the first figure is 1, and the perimeter of that figure is going to be 2 times the width and 2 times the length. And I may be using the width and the length interchangeably because it really doesn't matter in this situation. So we have 2 times 1 plus 2 times 6, and when you get those together, you get 14 when you're adding. So the ordered pair is 1 comma 14. What we do is we take the 1 and we take the 14 and we put them right next to each other. We're going to do the same thing for 2, 3, and 4. So take a moment to write those down and then compare with what I have. Okay, so now that we have our table filled out, let's try to figure out if there's any patterns in the table and then write an equation and say some words about it. So looking at this table, as you can see, we are multiplying 2 times the number of rectangles, 2 times the number of rectangles, etc. 2 times the number of rectangles. So that keeps changing. That 1 through 4 right there is based on the number of rectangles. Now this other value right here, 2 times 6, that does not change. So what is 2 times 6? That's 12. So what we're going to do is keep adding 12. So the varying quantity is going to be the x. That is the number of rectangles. So our equation is going to be y equals, y stands for the perimeter, 2 times x plus 12. And we got the 2 times x from the 2 times the number of rectangles, the beginning part of that middle column, and then the 2 times 6 is the 12. So now let's write a little bit of words to describe that, and then we'll make a graph and we'll be done with this one. So here's a little summary. We multiplied the number of rectangles by 2 to take into consideration the top and the bottom, and then we added 12, which we got by 2 times 6. That's the left and the right of each figure, and that's how we got the entire perimeter. So feel free to pause there to write that down, and then we will move along to making the graph. Now we're going to have the number of rectangles on the x-axis, and the perimeter on the y. And on the x-axis, I'm just going up by ones. And on the y-axis, I'm going up by 4s. And now let's plot our points. All right, there's our points. We have represented this relationship between the rectangles and the perimeter using a table, an equation, words, and a graph. In this example, we can describe the relationship by saying that the perimeter is a function of the number of rectangles. So now let's talk about what a function is. A function is a relationship that pairs each input value with exactly one output value. And a function is often described like a machine. So what happens in a machine is you input something, and we're going to be inputting the independent variable. Then you put that into the machine does its function, whatever operation, and exactly one output value comes out, and that is the dependent variable that depends on the independent variable that came into the machine. So that is an example of a function. And now there's a very specific type of function. It's called linear, and you've heard that before. Linear just means that it graphs as a line, and more specifically, the function whose graph is a non-vertical line or part of a non-vertical line. And non-vertical just means not vertical, so not up and down. And we'll figure that out a little bit more later. Now in example 2, let's use these definitions and figure out what to do. The table shows the relationship between the number of photos X you can take and the amount of memory Y in megabytes left on your camera's memory chip. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph. So take a moment just to reread the problem and look at the table at right. Okay, let's look at the rate of change between each row of the table, and I'd like you to write this down. So for the X values, they're just increasing by 1, but what's happening for the Y? It is going down by what value? It's going down by 3, so we're going to say -3, -3, or -3. So that's what's happening. Now let's try to figure out how to write this in words. So how does the memory chip work when you're taking pictures? What happens is that when you take a picture, there is less memory on the card because each picture takes up a certain number of megabytes. And in this situation, there is 3 megabytes taken up by each picture. So here's the words that describes the situation. The amount of memory left on the memory chip is 512 minus the quantity 3 times the number of photos taken. And the reason why is because the memory chip starts out with 512 megabytes. And each time a picture is taken, it loses 3 megabytes. So instead of keep subtracting 3 over and over again, we can multiply by 3. Just like when we add over and over, we can just multiply by that number to make it faster. So there is our words, and now let's write an equation to represent this situation. The amount of memory left is going to be the Y, and we start with 512. That is the original size of the memory chip. And each time we take a picture, we're losing 3 megapixels, or actually megabytes, and 3 times X. X is the number of photos. So there's our equation. We are going to use the table to make a graph now. So let's see what that looks like. And you can pause once I have the graph up to compare yours. Make sure you label the X and Y axis. Okay, as you can see, the graph displays the table at top, and the number of photos is increasing and the memory is decreasing. We will not connect the points because it is not possible to take 1.5 pictures, etc. And you may be wondering what this little symbol is, the little Z-like thing below 500 on the graph. That's just showing you that we're cutting out all the numbers we don't need. So I'm starting at 500. Now all we have to figure out is if it's going to be linear or not. So does it look like a line, and does it decrease at the same amount? The answer to that question is yes. The points do lie on a line, so the relationship between the number of photos taken and the amount of memory remaining is a linear function. We're going to write that down. You can too, and then we will just talk about the lesson check ahead. Okay, those are the words that I said out loud. Sorry about the crazy writing. My computer's kind of malfunctioning. So yes, it is a linear function because the graph represents a line, and also the table shows you that it's decreasing by 3 each time. Now, for the 4.2 lesson check, you can feel free to try it now, Or you can wait until we do problems together during class like this tomorrow, but just make sure you do it before the next lesson.